Today we are going to introduce the basics of machine learning. First, the difference between machine learning and the traditional programming is that programming, we developers create all the rules. All right, right? We code all the rules, and when any new data input come into our program, then our program will generate answers. On the other hand, machine learning, we give them data and sometimes answers, like supervised learning. We usually call them labels, and then they will learn the rules. They will learn the rules for us. So it's called learning. So here's the machine learning workflow. First, you need to prepare data. All right, the first of all, you need to have a lot of data, and then you need to evaluate. You need to find a way to evaluate the performance. All right. So we need to choose the right loss function. Today we are going to learn how to choose the right loss function for different kind of problems, and then we can start training. Training is the process of learning. So yeah. So when we talk about learning, we usually means, or when we talk about training, we usually means learning. Or you can see the optimization process. So the process is a iterative process. You will keep train your model a little bit, then evaluate your process. Right? Evaluate your performance. If you are not satisfied, go back to training. So repeat this process until you are satisfied. Your model is accurate enough, or the error rate is small enough. The error is small enough. So machine learning can be classified into three categories. I have three main categories. One is supervised learning. Another one is unsupervised learning, and the third is reinforcement learning. Supervised learning has a teacher that label the data. It's a nice way to say workers. So in fact, supervised learning requires a lot of workers to label the data, right? So it's a very tedious, very difficult tasks. On the other hand, unsupervised learning does not require the workers. It's ask the model, or it's ask the agents, the AI, to learn the model by itself. So unsupervised learning is more smart, it's more close to true intelligence. But the performance is so far not good. So there's a new method called self-supervised learning. Self-supervised learning. It's between supervised and unsupervised. It's actually more close to supervised. So self-supervised learning is to use structured data, semantic data like Wikipedia. So it may use Wikipedia as a training source, and then ask the model to do something like predict next word in a sentence. So it's try to hide a word in a sentence and ask the AI to learn how to complete a sentence or predict next word. So it's not. So this is not supervised learning because we do not need to label the data, right? However, the data is not totally raw data, right? The articles on Wikipedia has been written and edited by humans. So it's not totally unsupervised. So someone invented this self-supervised learning. And it turns out very useful, and this is the main method that train ChatGPT. So it's used to train ChatGPT, self-supervised learning. Okay. Okay. So based on the types of data, we can further classify the learning method into classification and the clustering. If your data is discrete is very common. Like classify images, there are multiple class, right? So they are not continuous, like dogs, cat, human. They are discrete data. If you are supervised and the data are discrete, then it's classification because it includes multiple class. On the other hand, if you are discrete data and unsupervised, then it's called clustering because we are trying to learn how to cluster unknown data into different clusters. If your data are continuous, there are a number like stock price, right, temperature, or they are continuous data, then if it is supervised and continuous, then the problem is called a regression. If the data are continuous and we want to apply unsupervised behaviors, usually the dimensionality reduction. Okay, so this is the difference. Based on the types of your data, we will have different type of problem to solve. So here's a cheat sheet from the scikit-learn. Scikit-learn is the most popular machine learning Python library. So you will use it in the future, and then it provides a cheat sheet to help you select the algorithms. Depends on your problem. Of course, today most problems are solved by deep learning. But in deep learning, still you have deep learning for classification, deep learning for regression or clustering. So you still need to know the difference between different problems. So let's start from here. Let's look at the cheat sheet to see what it says. So start from here. First, check how many data do you have. If you have less than 50 samples, you need to try to get more data. It suggests you to get more data. However, if you try, there's a branch of research that is study small data. It's called few shot learning. So if you have less than 50, only a few examples, there's some algorithms, some research help you to learn to increase accuracy. And the next step is to check if you want to predict a category. Category means class, right? Oh, it's difficult. Try to make my writing more recognizable. So category means class. So it's try to predict class. It's discrete, right? So it's a discrete data. In other words, it's if your data are discrete or not. So if it's discrete and do you have label? Supervised. So it means it's your learning supervised. If your learning is supervised and discrete, then it's classification, right? If your data are if your data are if your learning is supervised and your data are okay. Here's our discrete data. If your data in the if your learning is unsupervised and your data are discrete, then it's clustering, right? Clustering. So let's have part of discrete data. Discrete data. Okay. So on the other hand, if your data are continuous and supervised, then it's regression, right? If unsupervised, then it's the marginality reduction. So this part is continuous. Yeah. Continuous data. So it's the homepage of scikit-learn. So scikit-learn has not only tools, but also examples. So if you want to learn some algorithms, so you can check the document of scikit-learn. Scikit-learn. Okay. So okay, so we can roughly classify machine learning into 5 tribes. So it's proposed by Pedro Domingos, but I like this idea very much, so I put this into the slide. So first, the branch of machine learning is called evolutionary. Evolutionary. It's it's try to imitate the evolution process of nature, right? The fittest survive. So yes, evolutionary. The second one is called connectionist. Connectionist is try to imitate the connections of our brain. So maybe they should call brainist. It's about neural networks and deep learning. The third is symbolist. Symbolist. Symbolist is trying to find the reasons behind models, like a decision tree. So I think for machine learning, we will focus more on this branch of learning, because it's more important. And then Bayesians. So Bayesians are for statistics. It's based on Bayes theory. So it's here shows on the histogram. Histogram here. Histogram. And then finally is the Bayesians. Bayesians. It is Bayesians. And finally is the analogizer. Analogizer try to map the input feature. So for input data, you first need to extract the features and then compare with the training data to see the input is more similar to which class of the training data. Then you can do like classification. So it's called analogizers. So let's look more details of each method. So first, evolutionary is about the theory of Darwin's, right? The survival of the fittest. So Darwin says the one that survive, the creatures that survive, is not the strongest or the smartest. Is the one that can fit, or fittest, can fit the environment change, right? Like in the old time, the most strongest animals are strongest creatures are dinosaurs, right? But they are extinct. So this is we need to survive of AI, then we need to feed, right? We need to adapt. Okay, so but this branch of algorithm is not very popular. Honestly, I would say they are not very useful in most cases. Although it's maybe some genetic researchers, but not too many. So the most popular one is genetic algorithms. Still, you can use it like to for problems like searching the best neural network architecture, right? You can use the genetic algorithms. Okay, so the most important characteristic of genetic algorithms are first crossover, right? So yeah, so how we human evolve, First, we married and create our siblings, right? So it's crossover. We exchange our genes. So make a new child, new kids. So it's make babies, okay, babies. So this is how genetic algorithm evolve. First, we do crossover, change part of your model. And second, mutation. You can make some random mutate, right? Mutants. So like some people are just immune to COVID-19, right? So they survive, survive for the fittest. So somebody are not. But we human now can use science to help us to adapt, right? So that's genetic algorithm. Second is deep learning connection is it was called deep neural networks, but now it's called deep learning. So as you know, neural networks are trying to imitate the function of our neuron. In our brain, there are multiple neurons. Each neuron is connected to others, other neurons. So there's a long connection path called axon. And then when it's close to another neuron, there will be many branches. Many branches is called dendrite. Dendrite. Each dendrite has a synaptic, which can save information. So is how neuron looks like. So we can use a simple model to imitate the function structure of neural networks. So suppose each input data here, and we'll go through each neuron. Each circle is a neuron, and the neuron will connect to all the other neurons in the following layers. It depends on the type of neural network, or they have deep brain connections. But in this case, it connects to all the neurons in the next layer. Anyway, so neural networks is about connections, and each connection will have some parameters to learn. So weights. So it's neural networks. It's called deep learning now because we can now create very deep network. Before then, we cannot do that. So the third one is the symbolist. Symbolist is about finding the rules and the reasons behind the model. In the model, they want to understand what have learned. They don't want it looks like a black box. So yeah. So in fact, neural networks also learn many rules. Just there are too many. So we cannot see all the rules, or we cannot understand how it works because there are too many. But somehow we can visualize, for example, which neuron was activated to understand how our model works. So deep learning is not totally black box, or maybe we can say that they are partially black box. Okay, anyway, back to symbolist. Symbolist is try to learn a decision tree from data or some rule, and all the rules can be understood by human. All right, so here's a famous example. There are a problem called to calculate the survival rate of passengers on Titanic. They have the passenger list of Titanic, and then use the information. The list shows the age and the gender, or how many siblings a passenger have. So we can use a decision tree to decide the survival rate. So the first node, the first tree node is to check the gender, if you are male or not. Okay, if you are female or non-male, then your survival rate is high. 36. And then if the if you are male, then are you a child? Are you a kid? Or if you are older than 9.5 year, then it's you have a very high rate to die. Huh? You have a very high rate, unfortunately. Huh? If you are adult, male adult, or you are highly possibly to die in the accident. Huh? However, this decision tree is a little bit odd. Also, I suppose the sum of the probability should be 100. Anyway, I will find another decision tree. So okay, so if you are a kid, do you have siblings? Do you have brothers or sisters? If you have too many brothers or sisters, also your survival rate is low. Oh, I see. This is the rate of dying, the rate of death, and this is the survival rate. So yeah, suppose, yeah, okay. Or maybe it's not. Okay, so if you are a single child in your family and you are younger than 9.5, you have a high survival rate. Congratulations. Okay. Okay, another useful branch is the Bayesians. Bayesians just to say that anything happens, just the probability, right? We have a probability to win the lottery, right? Everybody has the probability of become a billionaire one day. Just the probability is very low, right? But still, we have probabilities. Of course, we have probability to be hit by cars or something else. So every day we should consider that we are lucky, as long as we are healthy. Okay, positive thinking. So anyway, what I want to say is that the Bayesian is based on the statistic and probability, and because there's a theory called Bayes theory. Specifically, it's about the conditional probability. Conditional probability. Right. So it's called conditional probability, which means it says the probability of X occurs given Y has occurred, Y has happened. The probability of event X happened given event Y has already happened. Okay. And then, okay, we will talk about more details. But basically, it's a Bayes theory. So Y can be the label, right? Y can be the label of our data labels, and then X can be the input data. Usually we mean X input data. Right? So this P of X, Y, means that given we have no labels. So let's look at this conditional probability. This one says that given the input data X, what's the probability of it belongs to class Y, right? So we can use this Bayes conditional probability to represent the probability of one of the class happen. That's Y. So yep. So you can see there are three input, So usually you have some prior knowledges and the data and the likelihood. And then you pass to the base theory, how you can predict the probability. So for data, usually we will calculate the statistics. So it will be a histogram, right? You have made a histogram before, have you? Use Excel, huh? So yeah. So there's a histogram here, and then there's a probability distribution. Usually we use a normal distribution, so it's like a bell shape. Okay, so the data, likelihood, and the prior, and we can calculate the probability of the input data belongs to each class. Yeah. So finally, the last one is called analogizer. The idea is that the like father, like son, right? The input data should be look like one of the train data, one of the training data. So depends on which class of the training data, it should be belong to the same class. The most famous algorithm is called K nearest neighbors. It's hard to pronounce the words, but its idea is very simple. So just compare the input feature with your training data. So suppose we have an input here. So this one is our input data. Input data. So we want to know which class it belongs to. We have two classes. One is red triangle, and another one is blue squares. So suppose k is equal to 3, and we find the nearest neighbors. Two are red triangles, and then one is the blue square. So the input data should be red triangle, right? I should draw the picture. However, if k equals to 5, it will say k equals to 5. Which I show you. K. You can see there are 3 blue squares and two red triangles. So now this class, the input class should belong to the blue square. So depends on the selection of the hyperparameter. Yes. Yeah. Let me check. It has been uploaded, but in somewhere in my website. So yeah, I will show it later. Because I'm recording the video, so let's do not interrupt it. Although not many students are watching my videos, but I try to make a better quality of the videos. Okay, so yeah. Sorry, I don't have enough time to update the website. I will update later. I always want to update before the class, but when I come to the class, it's almost late, almost start. So yeah, I will update later in the break. So okay, so now we know there are 5 different branches of machine learning. Each one has different assumption, right? And they try to learn from the nature or life experience. They have different assumptions, so they develop different kinds of algorithms. So there are 5 different types. But of course, now the most popular one is deep learning. But still, the symbolist and the analogizer has some works better than deep learning in some fields. Okay. So we know that depends on the type of data, discrete or continuous. We have different kind of problems. So let's look at the data types. This comes from statistics, right? So there are data types. First, there are 2 major types. One is discrete, or you can say not continuous. Another one is continuous. Continuous. And yeah, you can say the discrete one is categorical, or the continuous one is numerical. The continuous one is numerical. So it means the same thing. And the categorical can be further classified into nominal and ordinal. But the numerical can be further classified into interval and the ratio. So there's a way to remember that. I learned from CFA class, but it's called that sorry. All the first word of the 4 category are called what's wrong? Oh, what's wrong with my pen? I just want to say that the pen in this classroom is very good. It's now start working. Anyway, the first word of all the 4 categories are called NOR. Right, it means black in French. I don't know if it helps you remember it or not, but if you are French, it should be helpful, right? NOR. So first, what's a nominal? Nominal N means pen. N means name. Oh. Shh. So N means name. All right, nominal. Nominal so is about the labels or class. It's a very popular type of class. So nominal data are labeling variables without any quantity values. So you can use number to represent each class, but they are not represent any quantity. There are many examples like your gender. You can use 0 means female, 1 means male, but it's just numbers. Or it usually encoded by 100 encoding vector for machine learning. Also, which language do you speak? So there are many examples. Any classification belongs nominal data. Another one is ordinal. Ordinal also represent discrete. It's also represent different class, but it has ordered value. Now its value means something. For nominal, the value, the ID means nothing, but for ordinal, it means there are some order in their class ID. The order is meaningful and important. Like you can use a number to represent your educational background. First means elementary, second means high school, and the third undergraduate, fourth is graduate. So the higher number means higher educational background, right? So the class are ordered units. The order is meaningful. It's ordinal data. Okay, the next 2 are continuous data. Continuous data. First is interval, but we almost never use interval data. Seldom, very few, because it means continuous data, but the data don't have a true zero. One example is temperature. We have two temperature system. One is called Celsius, another one is called Fahrenheit, right? Celsius and Fahrenheit. They both represent the temperature, but they don't have the same true zero. Okay, but usually we want the true zero. Zero means nothing. So finally, the fourth one is called ratio. I don't know why it's called ratio. So it's the same as it's a continuous data, but it has absolute zero. Okay, so but it can be used for both descriptive or inferential statistics. There are many examples like the weight, height. So there are continuous data has true label, then it's then they are belong to ratio data. So here are a comparison between machine learning and statistics. So Hinton says that machine learning is part of statistic learning. So although now we have less and less math, more and more programming, but the fundamental of machine learning is part of the statistics. So in statistics, we call the model we train model. We call it model. But in machine learning, actually, we also call it model most of the time. But in machine learning, the parameters, the state parameters in statistics, so we usually call them weights, weight of the importance. And in machine learning, in statistics, the process of training data is called learning, fitting, right? So if you use scikit-learn, you can find that the function is called fitting. In machine learning, we call it the learning, or we can call it the training, right? Training. Oh, I see. And then, I can use my hand. I can use my finger, but I cannot use the pen. I don't know why. Training, My pen is broken. So, okay, another important concept is called generalization. We will talk a lot about the generalization. It's about in statistics. They do not highlight this concept, but it's actually the test set performance. So we usually split the data into train data set and the test data set. For fair evaluation of your model, you should not use the test data to train your model. The test data is supposed to be unknown, have never seen by the model. So that the generalization is talking about the true performance on the unseen, the test data set. So in statistics, they call it test set performance. Okay, then the next one is called regression. In machine learning, there are supervised learning, but in statistics, again, they didn't highlight this idea, so it's called regression and classification. And unsupervised learning is clustering and density estimation. The other two are just sarcasm. So the machine learning competition has high